So I create a video to explain my assessment. And so I have a document. Generally, I will do an inspection of an infinity pool, and then I will create a list of defects that need to be corrected. But I think the video gives a little more insight. So the first thing I'd like to talk about is the pool project that was built in Kingwood, Texas, and it was built 24 years ago. And we can see it's a beautiful looking pool. The design is excellent. And also, I'm going to mention some of the defects. So I want to talk about its virtues. And one of them is the basin size is a great size, and that the builder had an insight going back 24 years ago, which is very important to mention, that builders today don't actually have the same insight. He was knowledgeable about infinity pool projects because he did build a large basin, and basins are generally the number one defect. So the basin is a great size. So I'm going to cover now some of the defects, and the two main defects are the lack of waterproofing, and we can see that by looking at the white stuff that comes through the grout. And that white stuff, we use a technical name of efflorescence to describe that. So that's number one problem with the 24-year-old pool that will now be avoided for the next 24 years by doing what we call not waterproofing. We don't use that terminology. We use the terminology of damp proofing. But let me now talk about the other defect and how these defects can be solved, which I will go into and explain in more detail than my report will have. So this is the autofill system, and number one, it is the wrong autofill system. And it's too high. So the obvious idea is, you see the basin is quite a large basin. The obvious idea is let's drop the autofill down so that the float mechanism, that's this mechanism here, is adjusted so that it will kick on at around 12 to 13 inches, which is the minimum operating level. So it really should kick on 1 inch above that 12-inch minimum operating level. And the reason we don't use that autofill is because this valve, this float mechanism, and the whole contraption itself was never, ever, ever designed to go down another 1.5 to 2 feet. That's not the design. And so the main reason we see this is because it's illogical that with a canister that's only so shallow, that it's going to be installed this way. Now, just on the flip side of the other system, they are deeper. They're designed to be deeper. They're designed to go down 2, 3, 4, 5 feet. There is no real actual cutoff point, and that's an infinity basin autofill system. But what we need to look at here is not the wired system, not the system that's connected, but the system that's wireless. And this is a wireless system. So let's look at, I know they're showing in the skimmer, and I'm not suggesting we put this sensing device in the skimmer. I'm only showing how it actually is structured. So the idea is that when the water drops below a certain level under the sensor, then, oh, it's getting under its minimum operating level, then it triggers a valve. It sends a signal. Let's take a look at the schematic here. It sends a signal to the antenna, to a control panel, and then that signal tells a valve to open. So the opening of the valve is opening a water supply, which then feeds into the actual basin. So if we go back to that video that I was showing, knowing that this has a feed line with it, then that feed line can actually be used way back, wherever it is at the vacuum breaker, the pressure vacuum breaker, that can be used to put the valve there and then to open and close it. So the autofill system needs to be replaced. And the system we just looked at, let's go back to our system, is the Kona Labs wireless level smart system. And that's the best system under these circumstances. But under normal circumstances, I would not use this autofill. I would use the Jandy, and that has an infinity pool autofill system, which is my first preference, but not in this setup. So another defect is we see here, this is not calcium coming out, calcium hydroxide coming out of the concrete behind or the mortar behind the tile. And so this is actually just basically calcium that's coming out of the water supply when water wicks its way across this side and then it runs down the tile. So how do you stop this vertical wicking that is inevitable? Well, what happened, or what should have happened, is that the tiler needed to cut a water channel. And a water channel is just a vertical channel. And it's just like, think about a gutter around a roof. So a gutter around a roof is a water channel. It's a horizontal water channel, but it's the same concept. Obviously, we're talking much, much smaller proportions, and we're talking about doing a notch, which is a water channel, vertically in the wall somewhere here, which might be between the tile, for example. And that can just be left like just a shadow water channel and vertical. Maybe it can be, takes an angle grinder and he does a slit a number of times with his blade. And, maybe a 1/4 inch or so might be sufficient, maybe a little bit more, but just enough for that water to, prevent it from jumping across and wicking its way on the side. And that would clean up that problem in the future, which is coming actually from water wicking to the side. So now let's go into the main defect, and that is what we see here. The white stuff coming through is efflorescence. So where does efflorescence actually come from? And we need to identify it just comes from concrete. And it can come from the concrete structure of the pool, which was never waterproofed in the first place. And so that will leach its calcium hydroxide, number one. Or it can actually come from the actual mortar. So it's got two places, because mortar, which is what they use to float the wall, obviously that's cement, it has cement in it, it has calcium hydroxide in it, and then of course the structure. Now, then we can say that there are two causes to the problem. It could be the mortar is leaching hydroxide, calcium, and the gunite is or both. So it's not an either or, it can be a both. So keep in mind, whatever is waterproofed, talking about the gunite, the structure, the concrete structure, then that necessitates also a waterproofing coat on that. We'll talk about that in a moment. And then also, once that's waterproofed and that mortar bed is floated out, and typically 2 days later after the waterproof is put on, depending on temperatures. And then that mortar bed is put on, and then that needs to also be damp proofed, not waterproofed, damp proofed. If you hear me say waterproofed, I'm meaning damp proofed. So then what can we really say is the cause of the problem? We can definitely say that the primary cause is most likely the actual structure, because it was never waterproofed, and so that's leaching. But we need to go into something a little deeper now, because when we say it could be the structure, now we have something else that's going on too. So let me explain what happens when they actually do concrete structures, and I'll start that in a moment. So typically, and not always, because I don't do it this way, but typically pool builders will put it's a ply type of wood, it's only 1/4 inch thick or so, pegboard. They will actually, before they shoot this wall with concrete, they will tie pegboard onto the rebar on this side. And then they'll shoot from this side. So you can imagine they're shooting that wall, obviously with a hose, 70 miles an hour or so. And they're shooting that wall. And so they wait till it sets up. But the problem is that the pegboard, which is, it's very flimsy, when they shoot against it at 70 miles per hour, it vibrates and it shakes. And as it vibrates and shakes, that wall is shaking, the rebar shaking, the consolidation of the concrete is weakened. So in certain areas, it's just going to be inevitable, and especially when they're shooting, they may get shadowing. So that would mean that there will be areas behind the rebar where there'll be little holes. Again, because it's not consolidated properly. Then they come back around this side after it sets and they strip off the pegboard, and then they will shoot again a couple of inches, and then they'll, trowel it and make it as curved and smooth as possible. But that does not fix the problem. It's still, the problem could be inherent in the wall design. So what I'm saying here is, if that wall was not shot on rigid, then we could have, which I'm saying 99% of the time they are not, then there would be areas where that water can use it as a conduit path to actually then find the weakest points and then come out the other side. And that's exactly what water does very, very well. Now, I want to digress here, or segue back to this area. There's the autofill here, but if you take a look in this area here, there is a little tiny fountain that's coming between the cracks here of the tile. And I don't know how good this video will be, but it's only maybe a few seconds and it'll stop. But if you notice, there's a fountain right in this area. And that fountain is caused by hydrostatic pressure. So what am I actually talking about? So this wall, the angle of this wall, the way it's angled in this particular manner, it puts a lot of pressure on the wall, because think about it, there's this straight edge and that water's coming to a straight edge. If that angle had been reversed around so that angle, let's say it's a 45, is inside the pool, then there's less hydrostatic pressure pushing on the pool, because a little more surface area and the tilt of the wall. But with that hydrostatic pressure, this is my hypothesis to explain why that water is coming out the way it's coming out. That's definitely hydrostatic pressure. It's possible that it's being pushed out through the gunite and it's finding a way to come out at that point. And I say that because it really should be trickling, but it's got a nice amount of pressure behind it to make it come out as a little fountain off the wall. So it's very likely that it's found a pathway through the concrete structure, which is this side, then through this concrete structure, because this is a monolithic structure. And then, of course, it finds its way out there. So what I'm saying is this might be proof that there are these little holes and shadowing and voids in the wall. And if that's the case, then that requires even more preparation to overcome that problem. But I'll come back to that in a moment. So the main thing that we want to talk about too is what are damp proofing. Damp proofing the wall, and then damp proofing this section here. You might as well damp proof pretty much everything you can in the basin, just to prevent it from water seeping out. A very, very good idea to do it, because even this side of the basin is not damp proof. Pebble interior is not going to be waterproof. It is porous. So in terms of coming back to the probable cause of this problem, it's most likely, as I said, cause being the pegboard, the lack of consolidation. So what needs to happen is the first thing I would start with here is to test the strength of the wall. Now, I'm not guaranteeing that that wall is strong enough and that, this efflorescence will stop with damp proofing. There's no way to guarantee that, because the wall itself is the problem. And it can find its way out past the damp proofing material, because that water is inside the wall. And if that's the case, then obviously there will be deterioration. But I'm not going to cover that subject. I'm only going to say that, yes, the wall could be deteriorating. Yes, there could be, rust or going on in the wall. Again, I don't know unless there's intrusive testing done. If you want the intrusive testing, you do it. You get the intrusive testing done. If you don't, because you don't want to open up the wall and you don't want to know about it, which many clients say they don't really want to know what's going on, they should, then you buy a rebound hammer and I will show you what I mean by rebound hammer. And let's go into this. So the rebound hammer is this, and you can buy one off Amazon. And the rebound hammer will give you, it's not going to be 100%, but it will give you some information about the strength of the wall by virtue of using, basically, it's just releasing a spring at a certain amount of energy, and then it will give you a reading here on a graph as to a number, and then that number you need to check, is it are you going in on the horizontal, or you're going in on the vertical, the floor or the wall, and then you check the number. You do 4 tests, and basically with the 4 tests that you're doing, you take an average, and if there's anything less than 3,000 psi, then it fails the test, period. And this is going to give you some idea of how strong that wall is. And I have seen 2,500, especially where as you get down the bottom, because they're less consolidation, especially if the wall's very thick. And there's a huge bench in front. So we can say that bench in front, there's even further to get back to the rebar, if you think about it, because the bench is 18, and then you have a 12-inch wall, so that's 30 inches, and they're shooting that gunite. So, I mean, I would say the chances of having voids in that wall are extraordinarily high. So that'll tell you something, but you should get intrusive testing and find out really what's going on, because that wall then, again, damp proofing is not going to do it, and then it needs a different coating, different substance to actually strengthen the wall. It's like putting a shell over a shell. So you take it from maybe 3,000 psi or 2,500, and then you can make it 4,000, 5,000, 6,000, 7,000, whatever you want, depending on the thickness of the extra material that's put on, and that's all before the damp proofing is done. But that's not I'm not going to cover that here, because that is an entirely separate set of specifications to damp proofing and requires a lot more detail. So I'm just going to cover the damp proofing at this point. So in using this PDF, the PDF has many links to it which are relevant to this particular project. So if we're looking at, for example, damp proofing, it has some information about damp proofing, and then it goes into a link, and by clicking this, it will take us to a page, and on the page, we will take a look at the product, which is used on the negative and the positive side. So it's exactly the same product, and it's a flexible and waterproof cementitious product. You can basically open the videos, watch the videos, and then this is a product. It has a 5-gallon liquid, the catalyst, and then it has the dry cement product, which is mixed into the catalyst. And so you can take a look at the quantity that you need by studying some of the literature. But the reason that this is so good is because it's a product that can be used on a surface instead of being only for pebble surfaces or for tile surfaces or for specific types of material to be put over the top. It can be actually used with any material. So unlike some of the other damp proofing products, and it does say it's a waterproof bond coat. So it can be used for the pebble as well. So if it's being used, it can actually be used for pebble. Remember, on that pool wall, that infinity wall, it needs to be waterproof the top and the sides, and then into the basin, and then the entire pool typically should be, because again, pebble is not a waterproof substance. So the positive side is this side, and the negative side is this side. Now, there is a bench on that other side, which is this side, and that whole bench needs to be waterproofed. Now, one thing with the basecrete is that there's a certain texture that is necessary. So when I say that, what I'm talking about is it can't be completely smooth. They have a specific texture. It's a 3D texture. It looks like a little bit like whipped cream on a cake. So it's very rough and it's very undulated. And what I'm saying is that is a texture that the tiler needs to create. Now, one key factor about the Basecrete product that the tiler should know about, and hopefully he doesn't learn this through experience, is that it's better to put one coat than to do a double coat. Now, even if the instructions still say, they shouldn't be saying, but they were supposed to be have been updated. You do one coat at maybe about 1/8 of an inch thick, maybe a bit less, 3/16. 1/8 or 3/16. Let's say you do 1/8, and not 3/16. That's way too thick. That you do one single coat of it, and you make sure that it's very well textured. Now, a very important key factor was something that was brought out in a video with the owner, Vito. And Vito said that, okay, we had failures. There will be failures. They have had failures. Any damp proofing product can have failures. And we found that when people were putting it on, so they're troweling it on, or perhaps they're even using a brush or something, trowel, brush, a roller, I should say, that they were taking it off. So in the two coats, they put one coat on, then they went over and waited a little while. They went over, they put the second coat on. When they put the second coat on, they were taking the first coat off. So he came to the conclusion that it's better to put a thicker coat on the first time, one time, and then put the second coat on. So one thing that you need to be aware of in the material selections when you pick this Basecrete cementitious product, you can call Vito and talk to Vito. It's a good idea. But secondly, you need a sealant, a polyurethane sealant for any of the pipe penetrations. Now, I don't know if it's exactly this particular one. You want to check with him. And I can't recall if it's this one or if it's another one, but I'm just giving an example that it needs to be underwater, 100%, a silicone adhesive, and not something for a roof or for a door or for a window jamb or something like that. They're called waterproof sealants, but they're not applicable to anything underwater. So you need something that will go underwater. So if this is not the product, then you need to ask Vito what he recommends to use around pipe penetrations. And you have returns, you have pipe penetrations, the drains of pipe penetrations, the inlets of pipe penetrations, any pipe that's sticking in the pool. One thing I want to mention also, skimmers generally leak. So the skimmers should be tested, and especially around the throat of the skimmers, they need to be sealed. And generally something like this or something equivalent to that product will be enough to seal around the actual skimmer. So remember that while the gunite, the shell, the structure, if the structure does not come into the right PSI, then you need to consider that you may have voids in there somewhere, logically, and that then you need to come back to me and say, what do we do now? And we can go into another protocol. At this point, we're going to say the wall is okay, assuming it is, don't know. You can damp proof it with Basecrete. Before you damp proof it with Basecrete, or after you damp proof it, you take the silicone as sealant, the polyurethane, and you go around every pipe penetration. When you do that, it assumes that you're going to chip out some gunite, you chip out all the plaster, you chip out the gunite, and you create a nice bowl around the pipe so you can get some good packed material in there. And then, of course, pebble or plaster, later they come in and they go over the top of whatever you've put in there. So the Basecrete can actually then, once the mortar has been floated out on that infinity wall, the Basecrete can be put back on. It doesn't have to have the same texture. It doesn't need to have a scarified texture that it had to have for pebble, adherence of pebble product. But it does need to have something over the top of the floated mortar bed. And then, of course, the thin set goes on the back of the tile and it goes on to the mortar, and that's it. You've damp proofed the concrete. structures. And remember, you need a vertical channel. It can be a 1/4 inch deep. It just needs to be a couple of blades wide where it's cut, notched. It can be damp proofed or something in that. Waterproof, maybe even do a different type of waterproofing in there. And that's to have the water prevent it from wicking. So what we're going to look at here is if we see the bottom of this basin, we're going to see there are 4 drains at the bottom and they're very close. So if we assume at this point, I'm assuming that 2 drains, the 2 closest drains to each other, are T'd together. They're not to current code. They may have been back in those days, but they're not to current code. So what needs to happen, wait, there we go, is because they're too close, one of the suggested ways to fix it and get the distance between them, which should be 3 feet from edge of drain to edge of drain, not middle, but edge to edge. One way to fix this problem, not only in the basin, but if we look over here, it's also in the pool. And then if we take a look up the top, we're going to see exactly the same application in the spa, is to put in 1 drain instead of 2. And when I say 1 drain, I'm going to suggest in my document, we take a look in the document, we have the Paramount 20-inch drain. If I click on that, it will have taken me to this page. And what we're looking at here is we're looking at a 20-inch drain, which basically is unblockable. And it's just, obviously it's pebbled over the top, but there it is there. That's the guts of it. And it is put in place and you can't see it. But the main thing is you can get rid of the 2, put 1 in, chip out, get it in, and then get it all in. Obviously you want to get it in, get it worked out before you waterproof, not after, before. Get rid of the other drain. You're teeing into this 1 single drain. And so obviously some use a chipping hammer or something. And then put this in and then get the right color because you want to match the colors, interior colors, instead of black with gray in pebble, you have the same color. And make sure you're picking your interior color. And then that solves all of the drain problems that we just saw in the photo. Again, it's not just the basin, but it's also the pool and the spa. So I'm covering now the safety element, and that is one of the safety elements. So keep in mind when they remove the pebble, they should take if you want to waterproof this structure properly, that pebble all should be removed and then waterproof it right to the gunite, and then they reapply pebble. What they want to probably try and do is just chip it out so they get a 3D profile. And when they get their 3D profile, they say, that's good enough, and we'll just pebble over that. Well, again, you're going to take a risk in the other areas. I'm not talking about the bench. I'm not talking about the wall. I'm not talking about the basin because we're assuming you're going to have that chip back enough to waterproof the gunite. But in the other areas, do it right, do it the right way, or otherwise they're going to do it their way, and you're not waterproofing or damp-proofing the whole structure. So you should damp-proof everything, chip it back to the gunite. And mainly because this pool's sitting up, you have fill behind it. You don't have virgin soil behind it where it's nicely compacted back there. It's in the ground. It's seated down in the ground. It's got virgin soil. No big deal. You wouldn't have to really worry about waterproofing the whole thing, but this is not. This has fill dirt. So fill dirt likes to be like a capillary action. If there's going to be water coming out, it's going to want to suck it out. So type of tile, 1 piece on the top, no joints, obviously. And then, of course, you're going to have not pebble on the inside. So here what they did is they brought pebble on the inside to this angle. So on the inside, where the water is, there's pebble. That should be a tile line. We talked about that. Run a tile line there. 3 inches is sufficient. And then I want to talk about the height of this wall to the skimmers in a moment. And then the tiles here, these are 12 inches wide. They're too wide. You get a little kick out where the tiles are coming together. Not a good thing. They should be 6 by 12. So if you had taken those tiles and turned them vertically and had the 6 inches wide across there, would have been a better setup. So what happened here is and this happens regularly, the infinity edge is up very high. And that edge, which is 1.5 inches to 2 inches, the water's up 1.5 inches to 2 inches down from the waterline tile, is it's too high in the skimmer throat. So this edge can be, ground down 1.5 inches. And I said it couldn't, but then I thought about it. It can be. And then you basically want to aim that the finish of the infinity edge gives you 3 inches. So you want 3 inches down so that the skimmers operate properly. Because if the water's too high in the skimmers, they're not going to operate properly. The optimum is 3 inches, or maybe 3.25 inch or somewhere there. So you can drop the level down and it will not conflict with the spa. Because the spa itself, you want the tiler to be very aware that obviously the spa has to be at least 1 inch higher than the infinity. And I have actually seen it in reverse. I have a construction defect case in Florida where unfortunately the infinity weir is lower than the actual, not the infinity, the spa weir is lower than the infinity edge. So as long as the tiler is aware that he needs a 1 inch difference, that's got to be higher on the spa than on the infinity. Again, we see code. This doesn't work to code. They're way too close and it should be repaired. If you don't repair it, then whoever does the repair is then liable for any problems later, code violations. If it's going to be inspected, the inspector is going to reject it. So if there are inspections, which typically there are, then they will reject it if it's like this. So while I was here, I saw bubbles coming out of some fittings on the wall over in this area. Let's see if we can get those fittings on the edge. Okay, right over there. We saw bubbles coming out here. And I don't know yet, but just so I'm very clear. Either it's because the O-rings in the pump lids they need lubrication, they're old, they are no longer flexible, they're not sealing properly, they need to be changed. I would change the pump lids because they're old. I don't know how old they are. I know the pumps have been changed. Change the pump lids and get the O-ring with the lids, change those out, test it. If you're still getting air coming in and you see bubbles coming out of those returns, it has to be on the suction side, basically. So you have a suction leak. So you want to, get the system tested as well if you do have bubbles. It would be a good idea while the pool is filled to test new lids, new O-rings, so that you can eliminate a suction side leak. Because if it's not coming from the O-ring, it would imply it's coming from somewhere else. Remember that when you do the skimmers, that you go inside the throat of the skimmers, you chip out all that, whatever there, and then you go back in and you basically seal up in those areas. The other thing I notice is water chemistry here is really bad. I can tell by all the interior. I would think that autofill running all the time. Let me think on that, because it keeps running and running. So it's adding more water in there. And so it's diluting the chemistry. It shouldn't be doing that. And at some point, it has to be filling up. I suppose it turns on and turns off. Anyway, okay. But I'm saying that there's something going on with the balance because of the way that looks. So we know about air bubbles in there. We know about all the stone that's going to be replaced. And the other thing is we know we have staining there. I'm not going to go into the staining, but there is some metal staining in there too. Any of the cracks around the edges, around these edges where there are cracks, those cracks, they need to be sealed. And I'm talking about the coping stone, obviously. I hope. Let me see. Okay, let me go into some. So this coping stone, wherever there are cracks, they need to be chipped out, taken up. You find any voids under there, fill those and then regrout it. So one more thing. So the last thing I'll talk about is the vacuum breaker. And this is a vacuum breaker. Click on the link. It will take you to this page. And this is a 2-inch vacuum breaker. And this is what you're going to want to use. $346 and not easy to find at 2 inches. I had to look a long time. I actually found one at 2.5 inches. I don't find them anymore. They're probably just very expensive, but even a 2-inch copper is $350 plus tax and delivery. So, but that's what you need to use, and that will be sufficient on, let's take a look at what I want to show you next. So not quite that. So let me find my picture, this one here. So there's a vacuum breaker. This tells me that the builder was advanced because this is a very unknown detail. And for most builders, they don't have a clue about vacuum breakers. They would put a check valve on down there and it would fail. So the vacuum breaker, which is here, is obviously open to air. Whenever the water pressure, when the pump turns off, there's no water pressure, that atmospheric pressure is going to drop any water that's held in the pipe at that point. And so that brass vacuum breaker that I showed you, that's what you're going to use there and to replace this. Now, apparently this is too low because every time this shuts off, the water level in the pool comes down 1 inch. So that means that it's siphoning back to the basin, that 1 inch. It could be 600-700 gallons that's siphoning back. So that was 1 inch too low. So this needs to be cut and extended up. So whenever you put one of these in, you want to make sure that you're up above the spa level, not the pool level, the spa level, because that spa level is 1 inch higher than the pool. That's probably part of where he got caught out, was on this, maybe on the spa level. I don't know. But anyway, go up on the spa level, that extra inch. And you can see how high he made this, but I think he eyeballed it when he did it. And again, it's 1 or 2 inches too low. So a great thing to have. You need to insulate it because in winter it can freeze. Just insulate it would be a good idea, and that's going to prevent siphoning all the pool in via the basin and out via the basin. So just one final thing, when the tiler works on this edge to me was fairly close to level. It was a very good job. He needs to be make sure that he has it level across the top. He's going to chip it down. He makes it level. One thing that's a good idea when it's all being damp proofed, basically, is to fill it and let it fill. Make sure that all the plugs are in the inlets, the plugs are in the drains. Everything's plugged up to make sure it doesn't drain through, those areas. You're going to probably say, well, what about the weep holes, for example? Okay, you do have a problem with the weep holes, with those that, to some extent you can fill it even though you have a couple of weep holes still there open. But anyway, if you don't want to flood test it, the tiler needs to make sure he's very level on the infinity edge. And also, because of the nature of this edge, the way the edge is slanted, that all the water goes up against the flat edge on the inside, that it pushes a lot of hydrostatic pressure on that wall. So he needs to make sure that he's waterproofed. He doesn't have any little pinholes around the place. You do one coating of basecrete, and you get a scarified surface. So it's got to be a very 3D surface, because when they come to do pebble, if they don't have the hills, valleys, and all the little undulations, then the pebble will not adhere to the basecrete. And yet it will adhere if you have the right scarified textured surface. So that's everything. I've covered the damp proofing. I've covered the test hammer using the rebound test hammer. I talked about the autofill and what systems should be used on the autofill. I talked about the hydrostatic pressure of that wall, to be very careful about waterproofing that wall, and grinding it down to get that 3-inch water level for the skimmers. And then I talked about the spa level being at least 1 inch higher than the pool level. And one more thing I want to cover just very briefly. I found another thing. So the heater is supposed to have a sediment trap right here. And a sediment trap is just a vertical gas pipe. It's a T with a cap at the base. And all of the impurities, just as they go into the heater, they drop out. There is no sediment trap here. It's going to wear out the heater sooner than later. One more thing here, I would take advantage. You have electricity here. You have a great setup. I would suggest put an ozone system there as a sanitizer. It's a great supplement, and it's going to cut down chlorine use. You have a great setup here. They're very easy to install. A ozonator on the pool will cut down chlorine by up to 50%. So this is the pump room, and this is not the way to plumb a pump and filter, but the builder didn't think ahead. And so what happened was he didn't communicate the size he needed. And then he decided he was going to build it into the box, which he did. This is a really big problem here. So what's happening here is to have a 90-degree in front of a pump. It's going to create turbulence. It's also some sort of a reduced 90. It's not a sweep. And it's going to create cavitation. So even if this pump lid is changed and the O-rings changed, this here is really should be replumbed. Now, I don't know how, but I do know that shouldn't have a 90 in that point. And if some way this pump can be reconfigured to give some more room, then that would probably solve a problem with what we're seeing in the pool with the air bubbles that we're seeing. Okay, so that's everything. There is a report that goes along with this, and this video is just to give a bit more in-depth information to the builder, to the homeowner, so that you have a better insight as to what you should be doing. And that wraps up the assessment of the project. It gives my recommendations, and then that'll be followed with the report.